Hi, I'm Lars Vogt and I want to demonstrate you a very small prototype that I've developed, a minimum viable product for knowledge graph building blocks and semantic units. Before we start with that, I just want to remark that I just recently required very basic programming skills in Python, and I developed this prototype within 3 months. So don't expect high quality code and don't expect a very elaborate application. It's really just a proof of concept of some of the main ideas or some ideas of regarding knowledge graph building blocks and semantic units. I'm a biologist by education, so I just learned programming to provide a proof of concept basically for the feasibility of these two concepts. So the screen is organized such that to the bottom right you see a window to a browser. The bottom left, a window to my local Neo4j instance, so the knowledge graph application that I'm just demoing now is based on the Neo4j database. And then to the top left, a window to my Windows PowerShell. And here I will start the application now. So it's running and we check in the instance, Neo4j instance, it's a very basic query. Is there any node? Is there any statement? And it says there's no records. At the moment the database is empty. So I will go to localhost to access the web interface of the application, and it also says no graph, please initiate the graph. So I will initiate the graph now. And what happens is it loads the descriptions of the building blocks that this application is using. And we can see it here now. It should return a description, basically, of these different building blocks. So the application uses one item group building block, item group unit building block, that's for the papers, and then several item units building blocks for various entries in a paper, and then a couple of statement unit building blocks. The application itself is, as I said, for a knowledge graph, and it's a scholarly publication knowledge graph, so you can add papers and make statements about them, and that's what we're going to do. So I fetch here the DOI of a paper morphological evolution in the ant reproductive caste. So we will make some very basic specimen descriptions. I add the DOI and it communicates now with API of Crossref, fetches the metadata, and creates that item group unit for the paper with some of the item units attached to it. There's a research activity item unit and research objective, research method, and research result item unit linked to that paper. And we should see it here now. It's this graph here. We see in brown, that's the item group unit of the paper with a node representing the paper itself. Then we have a couple of item units in brown, and we have 3 statements in dark green, and then we have the actual nodes, the resources from these statements. We see we have a research activity, research result, objective, and method, and we have, as I said, the paper itself. Now, what we can do is we could add a research topic. Evolutionary biology. So what I do here now is I use the API of BioPortal that allows an autocomplete, and it does that autocomplete against a specific ontology that I've specified. And now this research topic has been added. And you see here we can save a snapshot of that live version. At the moment there is no version being stored or saved yet. except of the live version, of course. So we store that, and we have a first version being stored. Now, we can add to the result that it's about a multicellular organism. So this is against Uberon now, and I have to identify the multicellular organism. Where is it? Did I write it incorrectly? No. I'm just blind, I guess. There it is. So I'll add that. And it adds now a material entity item with multicellular unit with multicellular organism as its subject. Now we can go to that page of that item unit, and now we could specify that it has a certain quality, a basic reproduction number. And we can add to that basic reproduction number a value. And it provides even a 95% confidence interval. So we could say that the mean value is 3.4, and the lower is 3.2, and the upper is 3.6. And we add that. So it creates the triples that are required to have this information in a machine actionable way in the database. Here it's just one line of information, but in the database, we can load it here. We see we have here the multicellular organism. We have here basic reproduction number, and then we see all of this here is the representation of the basic reproduction number in the database. We have here the mean value. We have here the specification that is 95% confidence interval. Here we have the value for the lower confidence limit, and here for the upper confidence limit. Okay, and we store that in another version. But of course, it doesn't make sense that a multicellular organism has a basic reproduction number, so we delete that. That was just nonsense. And we see another feature of this framework, because if I now check, I still see that this statement is present. But if I go to the statement itself, I see here it says current version false. And the same for the specification that it has the quality. It also says current version false. So what we do here is we do a so-called soft delete. We set the information to be false, so it doesn't appear in the interface anymore, but the information is still available. The same would happen if I change a certain value within a statement. So we can do that now. We just add the weight. And now the statement that this multicellular organism has the quality weight has been added, and now I can specify the weight. So I just guess an ant has maybe weight of approximately 1.5 milligrams, and I add that to the graph as a statement, and it will appear also here. We will find it as I just have to find. Here we have the weight. I drag it here. So this is basically the statement. We have the weight. It has a scalar value with a measurement value of 1.5 and the unit milligram. But maybe I think this is incorrect. So I want to edit it. I want to say, no, it's actually 1.4 milligrams. Milligram with double L, of course. So I edit it. And now in the interface, it will appear as 1.4 just in some seconds there. But if we go here, we will see we now have two weight statements. We have two values. We have 1.5 and 1.4. And the 1.5 has current version false, and the 1.4 has current version true, and that's why it appears here in the interface. So this means we can have an editing list and show all the values that have been, so it's like an editing history. We can show all the values for each input field and for each statement and each item and so on. We can show the history. Now, here I want to add now that this has a head. So I add the head. And I want to also add that it has an abdomen. And what happens now is we have added to this partonomy two more entities. So we have three entities altogether, and three entities form a granularity tree, and we have that here. And the application automatically identified that we have a granularity tree unit and has added that semantic unit to the graph. And we can now fetch all the statements that belong to that granularity tree. Now, we want to add further that the head has a weight. We can do that. And that's approximately, I don't know, I guess it's something like 1 picogram. So we will add that. 1.0 picogram. And we want to add that the head has antenna. So we will just wait. And so here you could provide further weight measurements, because you can make errors in these weight measurements. So if you want to provide alternatives or further measurements, you could do that. That's why this appears here. Okay, I will add the head. No, the antenna. I'm confused. So we will add an antenna. And since the heads of ants usually have more than one antenna, I will add another antenna. That was too fast. So we'll go here once more, antenna, and there it is. So we'll add another antenna. Now we have a problem that we have two instances of the class antenna, and you see that here. The label of this instance is antenna, and the label of that instance is also antenna. And above, we see the label of the class and the ontology to which it belongs, Uberon. So we have that information here, but we want to change the label of the instance. We want to say this is the left antenna, and we save it. And then the other one is, of course, the right antenna. We can change that as well. Right antenna. What you see here is the metadata that is connected to this statement. So we added it now. Right antenna, and you can see here also the history, editing history of this item group. Everything that has been done here. So we edited that. What we can do now is we can also make statements about statements, and I just show it here for the confidence or certainty of that statement. We are very certain that this multicellular organism has a right antenna and that it's part of the hat, so we save that here as a statement about this statement unit. And we can see here in the graph, we have, first of all, we have the two versions already in the graph. We have the parthood granularity tree as a granularity tree unit in the graph. And here we have, to the statement, we have a certainty value associated. So, and what do we do next? We store this as another version. And so we have now 3 versions that should be reflected in the graph. So we have here 3 versions for that paper. We have one is the last stored version, and then we have further versions, and they are linked to one another in a sequence that is just reflecting the history. And then we can also take another look at the granularity tree, and we see it has grown. We have now the head with 2 antennae. We have the multicellular organism that also has an abdomen. Okay, so what we could do now is we could also go here and just delete that multicellular organism. So all we added is now gone except for that research topic statement. But we, of course, stored the versions beforehand. So we have our first version that we stored is basically identical to the version that we have now, with only the research topic being specified. You see here you cannot do any editing because it's a stored version. You can return to the live version. And then we have version 2 that we've stored. That's the one with the basic reproduction number. We have it here with the basic reproduction number, which didn't make any sense. And then we have the third version that we stored with the specification of the weight and the granularity tree and so on. So we have here the weight specified, right antenna, left antenna, weight is 1.0 picogram. So that's basically it, what you can do. Of course, you can go to the lobby. You could add another paper if you wanted to. Here we have a paper, and we could fetch the DOI. Just do that. And we could add another paper. Well, unfortunately, my OBS just has crashed, the software that I use for creating the video, so I had to reload everything. But nevertheless, we can add another publication. And again, it fetches the metadata, creates the page for the publication, which is an item group unit, and some of its associated pages. We see that here again with all the metadata. And now we can go to the list of entries, and we will have 2 papers from which we can now choose which one we want to have shown. Well, that's basically it. These are some of the main ideas of semantic units and knowledge graph building blocks and how they can be used and utilized in a knowledge graph application. And thank you for your attention.